All right, we're in chapter 3 on pretty much water. Water is in all living things. If you don't live in water, like inside your body, water pretty much surrounds all of your cells. And because of its water's ability to hydrogen bond, it can has some unique properties that other liquids really don't have. So just to review, water makes hydrogen bonds because it has these polar covalent bonds that are present. You can see here where you have 5 different water molecules and they're hydrogen bonding with each other. In water, the oxygen has a partially negative charge because it's holding on to electrons in its covalent bonds longer than the hydrogen is, and the hydrogen has a partially positive charge. That's due to the lack of electrons. So an oxygen from one water molecule would hydrogen bond with a hydrogen of another. Each oxygen has really kind of 2 partial negative charges, where each hydrogen has 1 partial positive. So they all kind of stick together, and within the solution or the liquid or whatever, the molecules are forming hydrogen bonds and then letting go of them and then reforming them and so on. So some of the unique properties of water is that it's cohesive, it moderates temperature, expands when it's freezing, and it's a really good solvent. Cohesion means the ability to stick together, and adhesion is cohesion is when 2 similar things stick together, and adhesion is when 2 different things stick together. Water will stick to things if they have a charge, because water has partial positives and partial negatives. So if you have other partial positives and partial negatives, water will stick to that potentially. Anyway, here you have a tree, and there's a big long column of water from the roots all the way up to the leaves. And, they're inside of these, actually what it ends up being like dead cells, like the wood itself. It's no longer living, depending on what part you're in. I'm assuming like you're in the middle. And then if you look inside these continuous tubes in a tissue called xylem, the water's all sticking together, so it does a cohesion, but it also sticks to the walls of the xylem and creates adhesion. And what that does is that allows for the water to kind of remain inside of the tree, and then when water evaporates out of the leaves, it pulls that column of water up, keeping the tree from dehydrating. Related to related to cohesion and adhesion, we have something called surface tension, and it's how it says how difficult it is to break the surface of a liquid. So water has high surface tension due to hydrogen bonding at the molecules on the very, very top. If you've ever done a belly flop, you'll know how difficult it is to break that surface tension. Some people have committed suicide by jumping off of bridges, and that's because when if they're jumping from high up, when they land, just because they're landing in water doesn't mean that it's going to be a soft landing. Due to that surface tension, it's actually a very difficult landing for the individual. So anyway, and that's I should say that's an effect of surface tension. I know there's a Mythbusters a while back where they actually looked at there was a myth that somebody had fallen off a bridge, but their tool belt fell off before them, hitting the water, and like it dipped into the water, broke surface tension, and they were able to survive. They tested it, and they actually found some positive results or similar results. So anyway, here you can see we've got the Chpater, and you really kind of see how it's got these little points of pressure. If you're arachnophobic, I'm sorry. I'm definitely not a fan. But anyway, it's got these little points where the Chpater is kind of resting upon. That's where the surface tension is coming into play. Another characteristic is that water has the ability to kind of keep temperatures fairly even. So water absorbs heat from the air, and it does that throughout the whole summer, and then during the fall it releases that heat to the cooler air. But water has the ability to absorb or release lots of heat, but keeping its temperature the same. Here's some definitions real quick about temperature and heat and energy. So kinetic energy is the movement of could be a number of different things. Could be large objects or small objects, but it's just energy that's moving. Thermal energy is actually just kind of the kinetic energy of molecules. Temperature is the average kinetic energy, and then heat is the energy transfer. Here, I'm going to zip through this. So water has what's called high specific heat, and that's the amount of heat needed to change 1 gram of something 1 degree Celsius. Water has high specific heat, and it doesn't just because it's absorbing all this heat doesn't mean that its temperature is going to change very much. Anyway, so why does it have a high specific heat? Heat's absorbed. When those hydrogen bonds break, it's released when they're formed. But the idea is that in order to get something to move faster and increase its temperature, you have to break those hydrogen bonds first. Then you can actually add more heat to that molecule and get it to move faster. So here we have a map of kind of the Pacific coast. And you can see, since water is just it's on the coast, it's actually keeping the temperature lower, kind of stabilizing a little bit more versus going further inland. Now, presumably, this is a springtime data, but basically everything on the ocean is like 75 degrees. If you go 40 miles inland, it's 100 degrees Fahrenheit. So it's a huge difference. Water also kind of helps us cool down, or helps us go through this process called evaporative cooling. And it's this idea that your skin sweats, or like if you're a dog, you don't have sweat glands, but your tongue, you get your tongue wet, and then the heat either will take, basically your body will heat up like the sweat. All right. It's adding a lot of heat, a lot of thermal energy. And then at a certain point, that sweat evaporates and then I was going to say boil off, but it basically evaporates. And then you're left with cold skin, because as that water, sweat, or whatever was kind of moving away, it took a lot of that heat with it also. One more interesting concept about water is that ice floats in liquid water, and that's because when water is getting cooled, at a certain point, all the atoms in that ice matrix get too close to each other, like the oxygen of one water gets too close to another, and then kind of repel out at like 4 degrees centigrade. So after it's cooled to a certain point, yeah, because you've got too many light charges together, it just expands and then freezes, and then basically you have something with that has less density than water, and it means it can float. Well, that's important because at some point we don't want Lake Michigan to totally freeze over, and if it did, if ice didn't float, that's pretty much what would happen. One last thing about water's special properties is it's a really good solvent for living things, and it has the ability to dissolve lots of different substances. So here you've got like a protein, it's getting surrounded by water, water's hydrogen bonding, and if you get enough, that protein is going to dissolve into water. Anyway, so I would just say water will dissolve a lot of things, especially if they have like a partial charge or a full-on positive or negative charge. Yeah, we'll just leave it at that. All right.